Hi, this is an open book explanation of chemistry chapter 4 about everything. So starting off, chapter 4.1, it's basically just scientist people name, not really important. So 4.2, the elements arrangement in the periodic table. So how it works is basically it's an ascending order of protons from left to right in the periodic table. There are groups and period. So groups are basically called rows, like the rows from here, group 1 to group 18. It can be determined by the number of valence electron in the atom. And there's duplet and octet. So duplet means 2, octet means 8. So next, periods. Periods is the one from the side going like this. So periods are like columns. It's determined by the number of shells filled with electrons. So you have to write number of shells filled with electrons. So again, group 1, valence electron in the atom. Period, that's groups. Period is the shells. So 4.3, group 18. Group 18 is known as the inert gases or noble gases. They have achieved stability. So basically, all the atoms in the group, in the periodic table, wants to be stable. But then group 18 is already stable. Achieve stability, electron arrangement. And the elements inside group 18 contains helium, neon, argon, krypton, xenon, radon, and organeson. So some information. Duplet is the only one. Helium is the only one with duplet, which is only 2 valence electrons, while the rest is octet. Some examples of these elements in daily life. We have helium, which is for hot air balloons, and I guess normal balloons as well. Neon is for advertising lights. Argon is to provide an inner environment. It's for like light bulbs. But then when you write, you must write to provide an inner environment. Krypton is used for camera flashlights and also laser eye surgery, but just write camera flashlights can already. Xenon is for lighthouse lamps and car headlights. So most of it is basically just lights. Its physical properties when going down, when going down, it's basically the atomic size becomes bigger because the valence, the shells filled with electrons become bigger. So like 2.8, 2.8, 0.8, like that. And when the atomic size becomes bigger, the melting and boiling point increases, the density also increases, the force of attraction also increases, and all the all the elements in group 18 cannot conduct electricity and is insoluble in water. So why the density increase, why the melting point increase, you just write because it needs more energy to break down. And yeah, now for group 1, which is 4.4 chapter. Group 1 is it's not stable because it's like the first group. It has valence electron arrangement like 2.1, 2.81, like that. So we have lithium, sodium, potassium, rubidium. The main three is LINAC, which is lithium, sodium, potassium. How do I say? When the atomic size increases, the distance between valence electrons and nucleus becomes further. Obviously, the nuclear attraction force becomes weaker, and it makes it easier to donate electrons. So how they donate electrons is because imagine the electron arrangement for lithium is 2.1. So to make it stable, the proton number remains, but the electron number from 2.1, it minuses 1 electron to make it 2, but then it's lithium like positive, you have to add the plus sign on top, so Li positive. Same goes with like others like sodium like this, -1. It's called electropositivity. And next we have group 17, which is electronegativity, which means it's the opposite of group 1. So one going down, one going up, like that. So we have fluorine, chlorine, bromine, and like iodine. This is the 4 main one, and there's also astatine and tennessine. So they have different physical states and colors. So like fluorine, we have it's a gas, and it's like yellowish green or pale yellow. Now chlorine is gas also. It's also like greenish yellow like that. Bromine on the other hand is like brown, but it's in liquid form. And iodine, with the out of the 4, it has like the biggest shell, most valence electron. It's solid and it's like black. Okay, so when going down in group 18, the melting point and boiling point increases. The molecular size increases when going down because it becomes bigger ma. The force of attraction increases, the molecules become stronger. It takes more heat energy, so it's the same thing with group 18. It requires more energy to break down, and opposite of group 1, so it's electronegativity, because when it increase in molecular size when going down, it will cause the attraction between the molecules to become stronger. Alright, and density also, the density of the element increases in the molar mass. The molar mass will increase. And some chemical properties. So group 17 elements have the same chemical properties because of the atoms of these elements have the same number of valence electrons, which is 7. Because it's group 17, 7, so it's like 2.7, 2.87. So it's group 1 is like 2.1, like that, right? So to accept 1 electron, it needs to plus 1. So imagine a chlorine atom, which is 2.8.7. It accepts 1 electron, it becomes Cl negative. But then for group 1, it donates 1, which is -1 electron, and becomes positive. But this one is chemistry, it's a bit weird. It's the opposite. So it accepts 1 electron, and then it becomes Cl negative. It's charged 1 minus, because it received 1 electron. Okay, you must write 1 minus, not -1. And same goes with group 1. It's 1 plus. 1 plus, not +1. Okay, that's about it. Now we have there's still changes in reactivity. So the reactivity decreases when it's going down. So it increases when the atomic size of group 17 increases. It will cause the distance between the nucleus, is the middle, and the valence electrons in the atoms to become further away, because the bigger it is, right? The force of attraction between the nucleus and the valence electron becomes weaker, because obviously if it's more further away, the attraction force is weaker. The tendency of an atom to accept electrons decreases. And yeah, like astatine, because it's a bit it's the fifth one. It's chemical unstable. It's unstable lah. The radioactive element. It's like not stable because it's too far already. And okay, 4.6. Now this is period 3. So the physical properties of period 3. So elements, it's like 2.8, 2.1, but as it's going down, it becomes 2.8. I mean 2.2, 2.3, 2.4, 5, 6, 7, and then the last one, it's actually stable, 2.8.8. So the atomic radius decreases, the atomic size decreases, the electronegativity increases. It starts increasing from top to bottom, and then it goes from metal to semi-metal to non-metal, and the last one, the non-metal, is the most stable one. So the changes in chemical properties are, so like we have like Na, Mg, you know, very common how do I say, elements used. And the chemical properties, so basically like Na20, I mean O, which is oxide, right? Oxide is negative, so when it, you know, you do the thing, the crossing thing, it becomes Na2 oxygen. So it's like basic oxide. So that's about it. So like basic oxide plus acid, it produces salt and water. Same goes with like acidic oxide plus alkali, it becomes salt and water. Same thing. So it's like, this is the element of the periodic table. There's basic oxides and acidic oxides. Oh fuck. But yeah, that's about it. Now for 4.7, it's transition elements. So transition elements, if you know, the periodic table is like this, and then here is group 1, 2, 3, which is the positive, I mean group 1, 2, which is the positive one. But when here is group 13, 14, 15, 16, 17, which is like the 13 is still positive, positive, 14 positive, and then it becomes negative. So like this, and then the middle, it's called transition metals / elements. So there's more than one oxidation number. It acts as a catalyst. It forms complete ions. You know, it forms complete ones. So like K2Cr2O07, some bullshit. And it forms colored compound. That's also one to remember. So they are placed in group 3 to group 12 in the periodic table of elements. You know, they are very hard metals in the middle. They are very hard metals compared to group 1 to 2. The solids have shiny surfaces. Okay, and they have like high melting, boiling, and density. Okay, because you know, it is what it is. Some special characteristics. It has more than one oxidation number. So oxidation number, which is like the +2, +3, like that. You know, K ion, like that, ion, whatever. So it has like more than one, okay? You have to just remember that. It can form complete ions. So like how would I say? It basically just forms the full formula lah. Okay? Like look at this shit. It forms the full formula. You cannot see. Whatever. Just listen. It acts as a catalyst. So the element like iron in process, which is like Haber or some shit, and then it creates ammonia. Like it's like a catalyst lah, you know. Catalyst, which like I have this like platinum, and then it goes through like hydrogenation, and then it creates margarine. I don't know what that means, but it acts as a catalyst, and it forms colored ions, which is like, what did I say, color lor. We got like green, orange, pink. Transition elements. Only transition elements can form these colors. And yeah, that's it for chapter 4. Bye bye.